So for my geometric interpretation, here's the y-axis. Here is my x-axis. And here is the z-axis. Grab a pencil in case I mess up. I'm going to extend x with my dotted lines. That's negative x. I'll just go, like I put a ruler next to this and I went straight back. I'm going to extend y straight back. So this is negative x, this is negative y, and negative z. So Q, negative 8. Let me start putting my markings. 1, 2, 3, 4, 5, 6, 7, 8. That's negative 8 on x. What point is this? Negative 8, 0, 0. So not Q yet. And then I need to go, y is 1. So on the y-axis I'll put, now look, I'm not going to go from here and then, I need to go parallel. I need to put in this line that's in the xy in the xy plane. So here's negative 8, 0, 0. I'm going to erase this negative 8. It's kind of in the way. Negative 8, 0, 0. And I'll go over parallel to y. What is this point? Negative 8, 1, 0. And then on the z-axis, go up 4 units. So I'm going to go up 4 from that parallel to z. 1, 2, 3, 4. This is point Q. Now let's plot point S. So S has 3 in the positive direction on X. So this point is 3, 0, 0. And then negative 2 on Y, I go parallel to X, parallel to Y. Let's put that, okay, right about right there. So that is 3, negative 2, 0. And then I got to go up 4 on Z. 1, 2, 3, 4. So this is point S. Now the line that we're looking for the equation of, I'll draw from S to Q and keep going, and I'll go this way. That's my line. Since the Z values are the same, this line actually is in a plane that is at a height of 4 on the z-axis, and that plane is parallel to the xy plane. So there's the line, and for my interpretation, I did this. I said, well, I'm going to use the point on the line to be Q. That's what I used in my vector equation right here. And vector R sub 0, that, now I'm saying position vector, and remember position vector means that the initial point is at the origin. So point 0, 0, 0 is where this vector starts. And then my R sub 0, if I used Q, is this vector. Vector R sub 0. Now, as t takes on different values, you end up with position vectors that hit different points on this line. For example, here's my vector equation that I'd gotten if I used that initial point to be Q. We did this. Vector R, which is XYZ, equaled vector, I'll put it on the next line, -8, 1, 4 plus T times 11, -3, 0. I want you to pick a value for T. I want you to pick T equals 1. When T equals 1, what is vector XYZ? If I plug in 1 for T, it would be this. XYZ would be -8, 1, 4 plus 1 times 11, -3, 0. It would be 3, -2, 4, which that is a vector whose terminal point is where? It's at S. When T is 0, if T is 0, I get vector R sub 0. When T is 1, I got this vector whose terminal point is S. I'm going to call that one vector R. In terms of my equation, but I'm going to call it vector R sub 1 because T was 1. Now, how about vector R sub 1/2? Let T be 1/2. Tell me what you get. When T equals 1/2, I would get -8. I'll call this vector R sub 1/2. I kind of just made up this notation, vector R sub 1/2. So this would be -8, 1, 4 plus 1/2 times vector 11, -3, 0. So -8 plus 11/2. 1 minus 3/2, and then the last one's 4 plus 1/2 times 0 is just 4. Okay, somebody who's quick with this, what is -11 plus 3/2? So that's -16 over 2. -5/2? 2 over 2 minus 3/2, -1/2. So, see now if I thought this out before class, I would have picked something that doesn't give me fractions right here. But this is what I got, so let's plot this. -5/2, -2.5 on X. -1/2 on Y. I'm going to put that point about right here. Up 4 units. 1, 2, 3, 4. My vector R sub 1/2 is here and has that terminal point. Now I picked something between 0 and 1 because I wanted to stay between S and Q. As T takes on values from 0 to 1, my vector R, the terminal point's hitting all of these points on the line. If I picked T equals 2, where would it put me? Out this way. I'd be off on my page. That's why I didn't pick t equals 2. But it would hit a point further down here on the line.